Welcome to this video on Math 82, Chapter 3 and 4 exam review. Here's our first question. So this question asks us to simplify the following expression, and our answer can only contain positive exponents. So my first piece of advice is for you to worry about the positive exponent aspect last. So let's simplify everything that can possibly be simplified, and then from there, at the very end, we will worry about changing any negative exponents that we have into positive exponents. Okay, so we have the power rule, the quotient rule, and the product rule. And we still need to honor, please excuse my dear Aunt Sally. So notice that these terms in parentheses, okay, y to the negative second power is still being raised to the negative third power, and so is z to the third power. Okay, so what I can do is I can rewrite this as y to the negative second power raised to the raised to the negative third power, and then z to the third power still raised to the negative third power. Then we have x to the negative fourth power. Okay. Now underneath, I also have this set of parentheses where I can apply the power rule. So I'm going to have x to the 8th quantity to the 4th, and I'm going to have y to the first power quantity to the 4th, and then over here I have x to the negative 8th. Okay. So again, I have to use that power rule. I have to simplify what's in parentheses first. Okay, so the power rule says that we do what with our exponents? Well, the power rule says to multiply them. So negative 2 times negative 3 is positive 6. Okay, 3 times negative 3 is negative 9. And then x to the negative fourth stays the same. Okay, again, here we need to multiply our exponents. So we have 8 times 4 is 32. We have 1 times 4, which is 4, and then we still have x to the negative 8th. Okay, so notice if we look upstairs at our terms, we have an x, a y, and a z. Nothing can be simplified or combined down there. However, if we look downstairs, we can see that we have two x terms. So the first thing I'm going to do is I'm going to rearrange the denominator. Let's rearrange the numerator too, so that everything is in alphabetical order. So I'm going to have x to the negative fourth, y to the 6th, z to the negative 9th. Again, I'm not doing any math, I'm just reordering things. Okay, then we have x to the 32nd power, x to the negative 8th power, y to the 4th. Okay, so I am going to apply the product rule here. Okay, the product rule says that what we need to do is we need to add those two exponents. Okay, notice that every time I simplify something, I still take an extra second or two to write the entire problem. Okay, and that's so that I don't get confused or lost. It also makes it much easier for me to grade and for me to give you partial credit. Okay, so we have 32 plus negative 8. Okay, and then we still have our y to the fourth. So 32 plus negative 8, well, that's the same as 32 minus 8. And what is that? Well, that's 24. Okay, so again, I'm just going to bring over the whole problem here. Okay, so now I want to start applying the quotient rule. Okay, so I have an x upstairs and an x downstairs. Okay, and what the quotient rule tells us to do is it tells us that we need to subtract our exponents. So I have x to the negative fourth minus 24. Okay, moving on to the y's. I have y to the 6th minus 4. Okay, and then the z's, right, there's only one z and he's upstairs, so we'll just write z to the negative 9th. Okay, so you can use your calculator. Negative 4 minus 24 is negative 28. 6 minus 4 is 2. And then, of course, negative 9 stays negative 9. Okay, so notice how quickly this really just simplified into 3 terms. Okay, so now that I only have these 3 terms to worry about, now I want to go back to the fact that they want only positive exponents. So x to the negative 28th is a negative exponent. Okay, and how do we make him positive? Well, we put him in the denominator. So x to the negative 28th is the same as 1 over x to the positive 28th. Okay, y squared, as you can see, is already positive. Okay, and also z to the negative 9th, he's negative, so he can come downstairs and he becomes positive. Okay, I'm going to erase this because it looks like a z. So that's y to the 2nd power. There we go. Okay, so that would be my final answer for this problem. Okay, so again, I know it's kind of tedious and time consuming, but my best advice on these sorts of problems is take your time, show every single step, okay, write out like I did, right, I wrote out 32 plus negative 8 so that I didn't mess up my signs or get confused. I wrote out negative 4 minus 24. I wrote that out so that I don't make a sign error. Same thing with 6 minus 4. So it takes a little bit of time, but it can save you a lot of points if you do that. Show every step, write out your work, and then it can award at least partial credit for the problem. All right, let's do the next one. So here we're asked to express the number in scientific notation. So just remember, scientific notation looks kind of like this. Okay, where you have one digit between 1 and 9, and you can have as many digits here after the decimal place as you want to, and then it's times 10 to some power. So that's what we mean when we're talking about scientific notation. Okay, so our decimal point starts here, and it needs to end right here, between the 1 and the 2, okay, because I can only have one digit, again, in front of that decimal point. So let's just kind of take a minute and count here, okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so in order to put this into proper scientific notation, I needed to move the decimal place over 9 times, 1.234. Okay, and because this number is much smaller than 1, okay, that means that I need to have a negative exponent. So my answer is 1.234 times 10 to the negative 9th power. Let's do the next problem. Okay, with this next problem, we're still working with numbers in scientific notation. However, we're actually going to do some calculations. We're going to do multiplication and division. Okay, so my advice is to first rearrange the numbers. So remember, this number here is called the mantissa. So I take all of the mantissas, right, there are 3, and I just rearrange them so that they're closer to each other. So I have 1.001 times 5.654 divided by 9.9, so it should be a 954. Okay, then I take all the powers of 10, okay, so, and I put those where they should go. 10 to the negative 33rd power, 10 to the 55th power, and 10 to the 44th power. Okay, and if you're wondering, well, why can I do that? How come that's true? Well, all of these numbers are connected through multiplication and division. Okay, so multiplication is commutative, right? 2 times 3 is the same as 3 times 2. Order doesn't matter, okay? So I can rearrange the top numbers that are connected through multiplication, and I can rearrange the bottom numbers through multiplication as long as the top numbers stay upstairs and the bottom numbers stay downstairs, okay? So what are we going to do next? Next, I can very easily, very simply, just type this whole thing into my calculator. Okay, you can do it in 1 or 2 steps, it's up to you. I'm going to do it in 1, so 1.001 times 5.654. Okay, then I'm going to divide that number by 9.954. Okay, again, I'm just doing this on my calculator off screen. Okay, so when I do that math in my calculator, I get 0.5688581. Notice I haven't done any rounding at all. Okay, just type that on my calculator. So hopefully, you know, that's something you could have done even before you started this class, right? Just evaluating things using technology. Okay, so now we need to use our product and quotient rule. Okay, and you can do this in 1 step or 2. I'm going to do it in 2 steps just so I don't lose anybody. Okay, so I'm going to use the product rule up here. Okay, so the product rule says when I'm multiplying 2 numbers with the same base, I need to add their exponents. Okay. So first I'm going to add negative 33 and positive 55, okay, and that gives me a positive 22, okay, and then I still have this, okay. All right, so bring this down, 0.5685, did I do that? Yeah, 581, okay, times this. Okay, so now I want to use the quotient rule. So the quotient rule says that what I need to do is I need to subtract these 2 numbers because I'm dividing 2 numbers with the same base. Okay, and again, bring down the mantissa, 5688581. Okay, so 22 minus 24, as I'm sure you know, is negative 22. Okay, so I'm going to come over on this side, 0.568581 times 10 to the negative 22nd power. Okay, and then the last step I have to do is, you might notice that this digit is a 0. So this is not in proper scientific notation, right? The first digit has to be 1 through 9. So to fix this, I need to move this over one step, one unit, okay? And if you remember, right, we've already done this before. You basically have a problem within a problem, okay? So if you think about converting 0.56851 to scientific notation, if I move it over 1, okay, that is going to become 5.6851 times 10 to the negative first power. Okay, it's negative first power because 0.56851 is a number that is smaller than 1. Okay, so I can rewrite this whole mantissa, okay, I can rewrite this as 5.68. I think I copied that wrong. I apologize. I left out some numbers. There we go. I'll erase that. Okay, so it's 5.68581 times 10 to the negative first power. Okay, and then we still have to bring down this other guy, 10 to the negative 22nd power. Okay, so last but not least, we can once more apply this quotient rule. Negative 1 plus negative 22 is negative 23. Okay, and then the other thing is, it asks us to round our final answer to 2 decimal places. So 2 decimal places is 6, 8. So to figure out if I keep the 8 or go up to a 9, I look at the number next to 8. So remember, 5 or above, give it a shove. Okay, so it's going to round up to 9. So the final answer is 5.69 times 10 to the negative 23rd. Okay, so again, the steps that I did is, first I rearranged things. I used a calculator to simplify the mantissa. That gave me this number, right? Then I used my product and quotient rules to get 10 to the negative 22nd power, right? And then I had to do these last few steps where I had to make sure it was in proper scientific notation, and of course I had to round my final answer. All right, let's do another problem. Number 4. Okay, so all we're doing here is really just multiplying 2 polynomials. Okay, it's kind of tedious and time consuming, but I'm going to walk you through it step by step, and hopefully you can follow here. Okay, so first I multiply these two. So I'm going to have 2m to the 3rd power times 2m squared. That gives me 4m to the 5th power. Okay, then I can multiply these two numbers. So this gives me positive 2m to the 3rd power times negative 2m. That gives me minus 4m to the 4th power. Okay, then I need to multiply 2m to the 3rd times 7, and that's going to give me 14m to the 3rd power. Okay, so then I need to move on to my next value. My next value is negative 3m. So I have negative 3m times 2m squared. That's going to give me negative 6m to the 3rd. Okay, so then I need to do the next one. So that is minus 3m times minus 2m. That's going to give me plus 6m squared. Okay, then moving on to my next term, negative 3m plus 7. Notice I'm out of room, so I'm just going to do it down here. So minus 3m, minus 3m times 7. That's going to give me negative 21m. Okay, so now we need to work on our third and final value, which is 5. So I have 5 times 2m squared. That's going to give me 10m squared. Okay, then we need to do 5 times negative 2m. Okay, that's going to give me negative 10m. Okay, and then last but not least, I need to do 5 times 7, and that is 35. Okay, so now what I'm going to do is I'm going to take these rainbow of terms here. Okay, so this row and this row. Okay, I'm going to try to write them all together, and then we'll combine like terms. Okay, so all together we have 4m to the 5th minus 4m to the 4th plus 14m to the third minus 6m to the third plus 6m squared minus 21m plus 10m squared minus 10m plus 35. Okay, so this is the part where we have to combine like terms. So I see these two are both power of 3s, okay, so we can combine those. Okay, then I can see that I have this term and this term, they're both square terms, so they can also be combined with each other. Okay, I also see that I have two m's, so those can also be combined. Okay, so let's start by writing our answer. So we have 4m to the fifth minus 4m squared, 4m to the fourth. Okay, 14m to the third minus 6m to the third is positive 8m to the third. Okay, 6m squared plus 10m squared is 16m squared. Negative 21m and negative 10m gives you negative 31m. And then last but not least, we have 35. Okay, so that would be your final answer. So again, it's a long, tedious process. If you're careful, like I was, and write out every step, show all your work, then you should guard against arithmetic errors and sign mistakes. All right, number 5, we are asked to solve this problem, okay, and it's a polynomial. However, there are variables on both sides. So remember, to solve these things, we have to use the zero product property, and I can't use the zero product property until I have 0 on one side of my equation. So the first thing I do in all these cases, if it's not already been done for me, is that I have to get 0 on one side. And in this case, the easiest way to do that is to simply add 5m to both sides. So I have 2m squared plus 24m plus 40 equals 0. Okay, then we have to review our general factoring strategy. So what is our general factoring strategy? Well, here it is, right? First, we have to look for a greatest common factor. Well, the greatest common factor here is 2. I can factor out a 2 from each term. Okay, so if I do that, I end up with 2 times the quantity m squared plus 12m plus 20, okay, and of course that's still equal to 0. Then I have to ask myself, when I look at this polynomial that's left over, how many terms do I have? Well, I have 3 terms, so I'm going to try to factor this using the AC method. Okay, so for the AC method, I have to look at what is A, and here A is 1. What is B? B equals 12. And what is C? Well, C equals 20. Okay, so I need 2 numbers that multiply up to 20 and add up to 12. And remember, sometimes you have to do trial and error. Okay, so for example, maybe you say, well, 4 times 5, that's 20. But that doesn't work, right? Because 4 plus 5 is only 9. Okay, so then let's say 2 times 10. Well, 2 times 10 is 20, and lucky for us, 2 plus 10 is 12. So this guy didn't work, right? But the second set of factors did. Okay, so now what I can do is I can rewrite this polynomial in factored form. So I have a 2, parentheses, m plus 2 times m plus 10 equals 0. Okay, so now if this was just a factoring problem, we'd be done. Okay, however, it's not. We have to set all of the terms equal to 0. So you could say, right, 2 equals 0, but that's never going to be true. So that doesn't result in a valid answer. So then we move on to m plus 2 equals 0 or m plus 10 equals 0. Okay. Sorry. There we go. Okay. So what we'd have to do here is subtract 2 from both sides. So our two solutions are m is equal to 2. Sorry, m is equal to negative 2 or m is equal to negative 10. So that would be the 2 solutions for this equation. Okay, let's do another problem. So here we have the same sort of thing, but again, we have a polynomial on both sides. So the first thing we have to do is we have to get 0 on both sides. Okay, so I'm going to subtract 7x from both sides. Okay, I'm going to subtract 8x squared from both sides. And I'm going to subtract 3 from both sides. So let's see what happens when we do that. Well, 9x squared minus 8x squared is just 1x squared, or 1x. Minus 46 minus 3 is minus 49, and these cancel out and go away. So we have x squared minus 49 equals 0. So going back to our general factoring strategy, we know that our GCF is 1, right? And then we have two terms, so we want to ask ourselves, is this a difference of squares? And in fact, it is a difference of two perfect squares, so we can factor it like this, okay? And then, of course, we have to do this extra step, so be careful, and always read your problem. Find out, is it asking you to factor something, or is it asking you to solve? If it's asking you to factor, you'd be done by now. Okay? If it's asking you to solve, you have to do this extra step that you can see that I'm doing right now. Okay, so make sure you show all your work. So the final answer is that either x equals positive or negative 7. Those are your two possible answers. Okay, let's do another problem. Okay, so for the rest of the problems, we're only going to factor. Okay, and again, you can see I've pasted the general factoring strategy here. So the first thing we always try to look for is the greatest common factor. If you want, you can take a minute, pause this video, and look at that polynomial. However, I can tell you the greatest common factor is 1. So now I say, okay, well, I have 4 terms. Let's try factoring by grouping. So factoring by grouping means that what we do is we just sort of throw the first pair of terms together, see what they have in common. And then we also throw the second pair of terms in together and see what they have in common. Now remember, because of this pesky negative sign here, I have to do this extra step here, like that, okay? Because that negative sign belongs to the 3x and needs to travel with the 3x, okay? So my GCF here is 3x squared. My GCF over here is negative 1, okay? So we have 3x squared times 3x plus 2, I want to say. And then we have negative 1, we'll pull out a negative 1, and we're left with 3x plus 2. So if you're wondering, well, why did she decide to factor out a negative 1 instead of 1? Well, the simple answer is that when we're doing factoring by grouping, I can't go any farther than this unless these two binomials are the same. And if I hadn't factored out negative 1, they wouldn't be the same. Okay? So now I have, I can pull out my 3x plus 2, and then I ask myself, okay, well, what's left over? What are the scraps? Well, I have a 3x squared, and I have a plus negative 1, or more simply, I could just write minus 1. Okay, so that is the answer for this problem. Again, the problem is asking you to factor, not to solve. Okay, so I can be done here. All right, number 8. Again, going back to my general factoring strategy, I want to find the GCF. Okay, looking at this problem, I can see that the GCF is definitely not just 1. I can factor a 5 out. Remember, we always look for the lowest exponent. So we have an m cubed, and 2 m squareds. Okay, so the smallest one is m squared. And then we have an n squared, and then just an n. So that would be n. Okay, so this is my GCF. Okay. However, I can't just stop here. I can't just identify the GCF and move on, because what it's asking me to do is to factor this. Okay, so to figure out what's left over after I divide, right, or after I factor out the GCF, the easiest way to do that is to divide all these terms. So 15 divided by 5 is 3, m cubed divided by m squared is m, n squared divided by n is n. Okay, then I have 2, n, and then these both cancel out, so I'm left with a 1. Not a 0, a 1. Make sure you have that 1 there. Otherwise, when you check your work, because remember, you can check this by redistributing this value, right? You can always do that for all of these factoring problems. And if you did that and you didn't have that 1 there as a placeholder, you wouldn't end up with the same answer that you started with. All right, let's do another problem. So here we're asked to factor. Again, we start looking for a GCF. In this problem, the GCF is 1. And we can see that we have 2 terms. So we want to see, is this a difference of 2 squares? Okay, and the answer is yes. X to the 4th is x squared times itself. And 256, if you're not sure, you can take the square root of it on your calculator, is 16 times 16. Okay, so we're going to have x squared plus 16 times x squared minus 16. Okay, now most people want to stop here. However, we always ask ourselves, anytime we're doing factoring, is there more I could do? Is there anything else I could factor? And if you look at this term here, look, This is another difference of two squares hidden in the problem. X squared is x times x, and 16 is 4 times 4. So I still have to bring him down, right? X squared plus 16, he's still hanging out. He's still part of my solution, right? But then I have to factor out x squared minus 16. Again, this is another difference of two squares. So that would be my final answer. All right, one more problem. So again, we start out by looking for our GCF. Okay, in this problem, our GCF is 2. I can factor 2 out of all three terms. So I have 2 times the quantity x squared minus 15x plus 56. Okay, so now I have three terms, so I'm going to try the AC method with just this polynomial in the parentheses. Okay, so I can see that A is 1, I can see that B is negative 15, and I can see that C is 56. Okay, so AC is 56, B is negative 15. So I need two numbers that multiply up to 56. Sorry about that. Okay, multiply up to 56 and add up to negative 15. Okay, so let's see. 7 times, left-handed. So 7 times 8 is 56, while 7 plus 8 is positive 15. Well, how can we make this a negative 15? Well, what we can do is we can have negative 7 times negative 8. The two negatives cancel out in this case and still give us a positive. However, when we add them, negative 7 plus negative 8, that gives us the negative 15 that we are looking for. So this guy doesn't work, and this guy does work. Okay, so we can use that shortcut method because our A is 1. So we have x minus 7, and we have x minus 8. Okay, and again, in this problem, we're only factoring. We are not solving, so we can just walk away at this point. Now let's look at number 11. So remember, in our general factoring strategy, the first thing that we need to look for is to see if there is a GCF that's greater than 1. So if we think of 49x to the 4th, well, 49 is 7 times 7, and 81 is 9 times 9. So numerically speaking, there is no number that I can factor out. Then we look at our variables. Well, we have x to the 4th and y to the 4th. So since our bases are not the same, again, there are no variables that we can factor out. So if there are no variables or numbers that we can factor out, we just say that the GCF is 1, and then we move on to the second step, which is to ask ourselves how many terms does our polynomial have. As you can see, we have 2 terms, so we look for a difference of 2 squares. Now it is true that both of these terms are perfect squares. However, is this a difference of squares? And the answer is no. This is in fact a sum of 2 squares. So what do we say about sum of squares? Well, remember, sometimes I give extra credit for mentioning that it is sum of squares, and then of course sum of squares by definition is prime. So the final answer to this question on factoring is simply that it is prime. So we're done. All right, now let's look at number 12. Initially it looks a little bit daunting, but we're going to break it down and get through this. So again, first we look for a GCF. You can take your time and go through this, but basically the GCF is 1, so that doesn't get us any closer. So then we ask ourselves how many terms do we have, and we have 3 terms. So we can use the AC method, or we can also recognize that this for what it is, which is a perfect square trinomial. So let me show you what that means. 49x squared is the same as 7x times 7x, right? 7x times itself. 81y squared is 9y times 9y. Okay? If this is a perfect square trinomial, then the middle term is going to be 2 times 7x times 9y. Let's test that theory. Well, 2 times 7 is 14. 14 times 9 is 126. Okay, so this is a perfect square trinomial. So by definition, we can factor it by taking the square root of the first term, which is 7x, and the square root of the last term, which is 9y. And then, because both signs are positive, we know that we have a plus here and a plus here. So this could be my final answer, or if you want to write it even more simply, we could write it as 7x plus 9y quantity squared. Now, let's assume I didn't recognize this as a perfect square trinomial, or maybe I've forgotten how to factor that. How could I factor this instead using the AC method? So let's look at that next. Again, if you don't want to use the AC method on this, if you're fine with a perfect square trinomial, you don't have to keep watching this video. But let me show you what we could do. So it's a little bit overwhelming, right? And the reason it's overwhelming is because we would get such large numbers. In other words, A is 49, B is 126, and C is 81, right? So AC is going to be 49 times 81, whatever that is, I don't even know. It's a huge number, and B is 126. So let's just take a minute and pause and reflect and think about if there's any way to make listing all the factors of 49 times 81, again, I don't even know what it is, I haven't even calculated it yet. Is there any way to make it easier? Well, I'm going to present an idea to you here, right? So AC, right, 49 is 7 times 7, isn't it? So instead of writing 49 times 81, I could write 7 times 7 times 9 times 9, couldn't I? Okay, so then let's explore this idea a little bit further. So what if I did 7 times 9 times 7 times 9, right? So these are all multiplication. Well, 7 times 9 is 63. So I have 63 times 63. Again, I know it's still going to multiply up to whatever 49 times 81 is, right? And then let's try 63 plus 63. Well, turns out 63 plus 63 is in fact 126, okay? And in this course, in Math OED 2, by definition, okay, if you have an A greater than 1 and you factor out the GCF and you still have an A that's greater than 1, it's going to be a perfect square trinomial. Okay, it's just going to be. When you get into Math OED 3, maybe not. Okay, we expand our repertoire when we get to Math 83. But for Math OED 2, for this course, okay, it's going to be a perfect square trinomial. So that's another hint that you can use. Okay, so again, the final answer, either way, is 7x plus 9y quantity squared.